Guys, we're talking about today inverse of a square matrix. First of all, what does the word inverse mean? Opposite. Okay. What's a square?
A square. I mean something with four sides.
Okay, four sides. All four sides are the equal. So if you have a square matrix, it's going to be a 2 by 2, a 3 by 3, a 4 by 4. We're only going to work with 2 by 2s for inverses. Okay, we're going to talk about proving that matrices are inverses of each other, and then we're actually going to find inverses of each other. All right, what this is saying right here is how to solve or to prove that there is an inverse of a matrix. What I need you guys to understand and to look at, when you are proving that one thing is a matrix or an inverse of another, you need to have this in your mind. All right, this is called the inverse matrix. 1, 0, 0, 1. All right, when we talked about functions and we were finding, we had, f of x. You guys said f of x. And I said if you found the inverse, you would write f what? Negative 1 of x, right? Same notation for inverse. So on your test, if you're telling me that something is an inverse, I need to say a with a little negative 1. If you don't write that, then it's not the inverse, and it's not correct notation. Comprende?
Sí.
Okay, thank you. All right, so if we're going to show that these are inverses of each other, you have to multiply. We're going to multiply them together. If they are inverses of each other, you will get that matrix that's 1, 0, 0, 1. But you have to prove that A and B and A are inverses of each other. Because when we multiply, it's not always the same thing. So the first thing I'm going to do over here is I'm going to find the product of A times B. So I'm going to rewrite this. Negative 1, 2, negative 1, 1. That's my A, correct?
Yeah.
And then my B is 1, 1, negative 2, negative 1. Everybody with me? Yes? So when I do this, how do we multiply? How do we multiply? First row, first column, okay? So when I do first row and first column, negative 1 times 1 is what? Negative 1. And then 2 times 1 is, so plus 2. What's negative 1 plus 2? 1. So now I'm going to go first row, what? Okay, first row, second column. So it's negative 1 times negative 2, 2. And then 2 times negative 1, negative 2. So 2 minus 2 is 0. Now what? Second row. First column. So negative 1 times 1 is negative 1. Negative 1. And then 1 times 1 is plus 1. So negative 1 plus 1 is? Good. Second row, second column. Negative 1 times negative 2 is 2. And then 1 times negative 1 is? So 2 minus 1 is 1. Did I create the inverse matrix there? Yes. So now we have to do the exact same thing, guys, but the opposite way. I'm going to take B, 1, 1, negative 2, negative 1, and multiply it by A. Negative 1, 2, 1. You can't just look at two matrices individually and say, oh yeah, those are inverses of each other. Sometimes they look like they are and they aren't, or vice versa. But you have to multiply A times B and then B times A to prove. So let's do this again. First row, first column. Sorry. All right, so I have 1 times negative 1, negative 1. Negative 2 times 1 is? Times negative 1, I'm sorry, you're right. Plus 2. So I get what? 1. Good. Good, good, good. So we have first row now, second column. 1 times 2 is 2. Negative 2 times 1 is? 2 minus 2 is? Perfect. You guys are getting the hang of this a little better. That's good. So now second row, first column. Second row, first column. 1 times negative 1 is? Negative 1. Negative 1 times negative 1 is? Positive 1. Negative 1 plus 1 is? Good. And then you have what? Second row, second column. So 1 times 2 is 2. Negative 1 times 1 is? Negative 1. 2 minus 1 is? So what did you just do? What did I do? I proved that they are inverses of each other. The way that you prove is that you multiply them together. You can say, quote unquote, forwards and backwards, or, you know, it has to be A times B, then B times A. But you should come out with the inverse matrix each time. Yes, sir?
So on both of the matrices, like, they're flipped. Like,
Yes.
is that a way to tell if it's the inverse, but you still have to prove it? But, like,
Sometimes it doesn't look like that.
yeah, but, like, can you tell that that's an inverse from that by itself?
Sometimes you can, and then sometimes you'll see if there's fractions or something involved. It's not as easy to identify. Some people are looking at it and they don't even see what you're talking about, that it's flipped. So, but yeah, I see what you're saying. Says to use Gauss-Jordan elimination to find blah, 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 blah. Don't worry about that right now. What we're going to talk about is finding an inverse when you are given a matrix. Okay? There are some things that you guys are going to need for today when we're finding inverses, and tomorrow when we talk about determinants. You're going to look at things called major and minor. What am I trying to say? The diagonals. Your major diagonal starts in the top left, goes to the bottom right. Your minor diagonal starts at the top right, goes to the bottom left. You guys see that? You understand what I'm talking about, like that? Okay, we're going to find something called the determinant. This is how we figure out what the matrix is, the inverse. To find your inverse, the way that you do that mathematically is to use this formula right here. Okay, you're going to put 1 over. You're going to figure out what this determinant is right here. And we're going to talk more about that tomorrow. And then you're going to do the switching like you see here. You're going to take your major, multiply those numbers together. Your minor, multiply those numbers together, and subtract. Does everybody see that? And then in order to figure out what the inverse is, you take the original one that they gave you. Look at your majors and minors. You guys see what I'm talking about when I say majors and minors? You switch the places of the majors. Do you see how A and D switch spots? Yeah. And you negate the minors. Do you see how B and C stayed in the same spot? But if they were positive in the original, they became what? Negative. So if they're negative in the original, they become positive. Okay? We're going to practice this a little bit. So you guys, some of you are looking at me like, what? Okay, so let's look. Find the inverse. Okay, we're going to find the inverse. In order to do that, my inverse, I need 1 over A times D minus B times C. And then I got to do some switching. D and A switch, right? And then what happens to B and C? They stay in the same spot, but what happens to they negate. You guys don't have to write that out every time. That could be confusing, I know, to some of you. This is what I like to do. I like to identify my majors and my minors. So 3 and 2 are what? Okay? These are major. And then we have -1 and -2, which are what? Minor. Okay. Once you figure out that part, the rest of this is really quite simple. What do I do with my majors and minors first?
You do the AB minus B.
Okay, so let's multiply. What's A times what's my major? What's A times A times D? Yep, sorry. 3 times 2 minus what? -1 times -2. Guys, this is where you'll make a mistake. You'll forget that it's a minus in the middle. where you'll mess up that 2 negatives is a positive. I would write everything out first and then move on from there. So if I simplify this, I have 3 times 2 is 6 minus, what's -1 and -2? So my answer here is 4. So to find my inverse, I have 1 over 4. That's going to go out in front. Everybody with me?
Yeah.
Same thing every time. So now I look at my original. What do I do with the 3 and the 2? You switch spots. So 2 comes here, 3 goes there. What do I do with -1 and -2? I flip the sign. So it becomes +2, +1. Everybody with me? So now, what do you think I do with that 1/4? Distribute it. What's 2 times 1/4, or 2 divided by 4? 1/2. What's 1/4 times 1? 1/4. What's 1/4 times 2? 1/2. And then what's 1/4 times 3? 3/4. So that's the inverse. Nope. You don't have to prove it, but what would you do in order to prove it? Multiply what?
The first one.
The first one by,
The new one.
then,
And then
then the new one by the first one. And you get the 0 matrix. That's the way you can check. Most of you will not do that. But that is a way that you can check. Does that make sense? Okay. Whoops. Okay. So, what am I going to do? What's my first step here?
the majors are gone.
Okay, let's multiply the majors and the minors. That's good. So, again, guys, I know some of you are going to skip steps. But I think the best thing to do is write everything out with your signs. Don't try and do anything in your head at first. Let's just figure out what we have here. So I have 3 times 2. Yes? 3 times 2. What's the sign that goes in the middle? Minus. What am I subtracting? -6 times -1. Everybody with me?
Yeah.
You agree, okay? So that's going to be the denominator of my fraction that's going to go out in front. What is... Say it again.
I'm gonna forget that. I'm gonna make it a plus.
Okay, that's why I'm telling you not to skip steps. Okay, well, good. Get that in your mind, and that's awesome.
It's 1 over 0.
Okay. Don't steal my thunder. What's 3 times 2, guys?
6.
6 minus. What is -6 times -1? 6. So my answer here is 0. What do you guys notice?
It's 0.
What's
Undefined.
0?
The denominator.
The denominator is 0. Can we ever have the 0 in a denominator?
No.
So right here, you guys can stop and say, there's what?
Syntax error.
There's no inverse. No inverse. It is, you're right. Syntax error. There you go. I spelled inverse wrong. There is no inverse. But just go through the process. Pretend it was 1 over 2, whatever. What would my matrix look like that I would be multiplying?
2, 1,
Top left would be what?
2,
2. Bottom right would be,
6,
3.
no, bottom right.
3.
Because what do we do with our majors?
You
We switch. What happens with the minors, Lauren?
Their signs.
Okay, they're going to become positive. Their signs are going to switch. Since they're negative, they become positive. Do they switch spots?
No.
No. Majors switch spots, minors switch signs. I don't know how else to simplify that to tell you guys that. But the reason this is undefined, that there is no inverse, is because what is in the denominator? A 0.
1 over.
Good.
1 over 5.
Let's look at the next one. You have questions, Sean? Are you okay? Okay. All right, find the inverse. What's my first step?
The majors.
What are my majors?
1 and -3.
So I have 1 times -3. John, what? Minus what?
1. No. Minus -1 times 4.
Perfect. So what is 1 times -3? -3. Minus, what's -1 times 4? -4. You guys are going to say to me, yeah, well, I already know it's +4. Okay, I'm telling you, personally speaking, I would write everything out so you guys visually see minus a negative gives me a Positive. You don't want to make sign errors here because once you make a sign error, what happens with everything else?
It's destroyed.
It's destroyed. It is wrong. You are correct. So what is my answer here? 1. So I'm going to take 1 over 1 and I'm going to multiply it. What does my new matrix look like? What am I going to plug in? What happens to...
Major switch.
Okay, major switch. So tell me.
-3 is in the top left.
Yep.
And 1 is on the bottom right.
Perfect.
And then it's on the top right it's -4. And then on the bottom left it's 1.
Perfect. Major switch spots, minor switch signs.
Is this just basically timesing it by 1?
Correct.
So is it not going to be just the same?
What do you mean just the same?
Like as in, you times the thing, the matrix by 1, meaning that...
Your original?
No, not the original, the
What
model.
were in yellow?
Yeah, the
Yeah,
ones in
yeah.
yellow.
I'm just setting it up so you can see it.
Right, I know, but just, wouldn't that mean that it's not inverse because it's not going to change any of the numbers?
It did change. Look at the original, babe.
No, I'm saying like, once you times the 1, it's not going to change what's in the yellow, because it's times 1.
No, but all you're doing is you're multiplying by 1. Like you can just leave it, but it still is an inverse. You're just multiplying by 1. Just because the number of values didn't change, their spots did.
Okay.
All right, guys. So Jonathan, how would I write my answer? What is my answer here?
Can I answer for you?
No, I'm asking John. What's my answer?
The matrix.
Okay, so read it to me.
-4, -3, -4, and 1 and 1.
Yep. All right. So guys, what is really important about the notation?
I thought that was a trick question.
No, it's not your question. What is very important about the notation? It's got the -1 because that indicates it to what? It's the inverse. If you guys tell me A equals, I'm taking points off because that's not true. That is not true. How can I check to make sure that these are actually inverses of each other? You guys can go through here and say, hey, I got this answer right. How can I do that? Tell me.
You multiply the first matrix times the
Times its inverse. So A times A
Yeah, and then you do the same thing backwards.
backwards. And what should I get?
0.
1,
The 1, 0.
Yep, let's do it. Let's do it just to check. Now, again, most of you will not do this. I know that. You guys, oh, I can't do that. Whatever. There are a few people that like to check their work and know, hey, when I turn this in, I know I got this one right. So let's check. My original matrix was 1, 4. No commas. 1, 4, -1, -3. Yes? And my inverse was -3, -4, 1, 1. Make sure I did my signs right, please. How do we multiply? First row,
first column.
first column. So when I have first row, first column, what's 1 times -3? -3. What's 4 times 1? -3 plus 4 is 1. Good. All right, same thing. We go where? First row, second column. -1, 1 and -4 is -4. 4 and 1 is -4 plus 4? 0. Next. Second row, first column. Good job. -1 times -3? Okay, and then -3 times 1? -3. Andrew, pick your head up, please. But like nothing. -1, stop. -1 times -4? 4. -3 times 1? 4 minus 3 is? Can I just stop there and go, I'm sure the other one works out.
You have to try the
No,
other
you
one.
should do the other one. Are some of you that get halfway go, I'm sure this one works out? Yes. Andrew, you're going to be the first one that does that. Josh, if you check one, Josh, I might give you extra credit.
What if I check my work?
No.
What if I check You already know I don't check my work.
I'm not checking my work.
What is your reasoning behind that?
I checked my
It's
work
too
on the
much
test. I'm not
effort.
gonna
Got it. Okay. Too much
It looks
effort.
right.
Good luck playing volleyball in college. Yeah, that's going to work out real well for you. All right. My matrix, my inverse, guys, was -3, -4, right? 1, 1. And my original was, excuse me, 1, 4, -1, -3. And Josh, I'm not ever going to give you extra credit. But. All right. So when we multiply, ladies and gents, I'm going to do it without my color coding. See if we can do it. First row, first column. So -3 times 1 is -3. And then -4 and -1 is Negative 3 plus 4 is? Good. First row, second column.
Negative 12.
Negative 3 and 4 is negative 12.
And then positive 12.
And positive 12, which gives me 0. Good. All right. Second row, first column.
1 plus negative 1.
1 plus negative 1. 1 minus 1 is 0. Second row, second column. 4 minus 3, which is 1. So, are you guys correct? Yes.
One is inverse.
What?
I was on the website.
On the website. All right. So, guys, you have WebAssign that is due tomorrow morning at 8 a.m. You guys have about 20 minutes almost to start working on it. Please do that. Does anybody have questions? Hold on. Does anybody have questions about last night's homework?